All right, now we'll study about graph traversals and the differences. We have studied BFS and DFS. If you didn't visit that video, you please visit that video. I'll be, giving it in the description as well as I'll be popping it off here. So yeah, we have studied about BFS and DFS. So in this slide, these slides, I won't be giving you more description. I'll be probably giving you the list of things and probably explain a little so that you can write it in the exam better. There is a previous year question that asks what is the difference between BFS and DFS, and they are asking theoretically. So these kind of questions need to be answered. Okay, so yeah, what is BFS? BFS radiates outward and it is already a level by level traversal that we have visited, right? We have seen if these are the nodes, it's not a graph. I have represented in a tree for you to better visualize. So we'll go level by level like this. We'll go level by level, which I've explained in the previous video. Whereas in the case of DFS, it'll go deep, and then if it doesn't find any unvisited node, then it will backtrack. We have this stack. We have studied this stack. Okay. We have studied this stack, and as and when we don't find any unvisited node, any unvisited node, any unvisited, yeah, as and when we didn't find any unvisited node, we have just popped it off and then we tried with the next node. For example, if you see, a graph like this, 1, 2, 3, and 4. Okay, so inside the stack, we'll first have 1, we'll have 2, we'll have 3, we'll have 4. Okay, now 4 doesn't have any unvisited node. What we'll do is we'll pop off 4 and we'll try if from 3, if once you pop off 3, 4, we'll have 3 now. We will try if there is any unvisited node. Okay, so again we'll pop off 3 and we'll try an unvisited node. You could see it will go deeper first and then we'll backtrack. That is what we have studied in the last class. Okay, so breadth first search uses Q as a data structure, and it, remember, this is very very important point, it guarantees the shortest path in unweighted graphs. Forget about the weighted graphs, which we'll study later, but if it is going to be unweighted graph, definitely it will give you the shortest path. And higher memory usage, why? Because it stores all the neighbors at each level. Because if you see BFS, if you have something like this, if you have 1, it's connected to 2, 3, 4, and 5 also. In the queue, we will, if you remember, in the queue, we have 1 here, and we'll have 2, 3, 4, 5. All of them are stored. You remember? So in the case of stack, in the case of DFS, if you see, the memory usage is less, because if you have 1 inside the stack, we will only store either of 1, 2, either of 2, 3, 4, or 5. We will only store 1. We will not store the entire, connected nodes in the case, like in the case of BFS. So definitely the memory usage is definitely higher in the case of BFS, but in the case of DFS, the memory usage is relatively less. Okay, that is the primary difference. Anyway, we'll have a table where we will discuss everything in detail. Okay, so DFS, yeah, as it doesn't guarantee the shortest path. Why? Because there could be a node that is so deep that in order to go to this level, let us say you are at 0th node, and the 100, the node could be at 1000 depth. Okay, in this case the memory would be full very fast, because it has to go deeper and deeper, and we never know how it will backtrack, and whether it will give you the shortest path or not. There is no such guarantee. Okay, so there is no guarantee in the shortest path and requires backtracking when a dead end is reached. As we've seen in the last video, we have backtracked. Okay, backtracking is required in the case of DFS, right? Generally uses less memory because, as you know, the storage is limited. If you have only, even if you have more number of nodes that are adjacent to this, it will only store any of one node. Let us say they have A, B, C, D, and E. It will only store E or C or D. Any one node will be stored. Okay, so that is the difference. Okay, we'll have the comparison now. Traversal is level by level in the case of BFS, And in the case of DFS, it goes deep first. Okay, and data structure used is queue, and DFS it is stack. And yeah, shortest path is guaranteed here. It is not guaranteed here. And backtracking is not required in the case of BFS, whereas it is required in the case of DFS. Of course, memory usage is higher. That's now I explained why it is higher. And of course, DFS it is lower. And time complexity, it is order of vertices plus edges. If you have like this, a graph like this, okay, what is the time taken for it? Definitely it is depending on how many vertices you have and how many edges you have. Okay, it is a combination of both in the case of BFS and DFS there is no difference. It is a combination of how many vertices and how many edges we have. So, and yeah, both are 0 and 0 order of V plus E. Okay, when is BFS used? When you want to find shortest path problems, then you use BFS. And networking, network broadcasting, like your WhatsApp broadcasting, those use BFS. And even if you have social network, those would use BFS only. And DFS, where it is used, cycle detection and topological sort. We have already learnt about topological sort. So you please visit that video and the maze solving. All these three are generally used. So remember, this is the side by side comparison. If you want to get very good marks in the exam, you just mention this BFS and DFS differences and mention them why the memory usage is higher, why backtracking is not required in the case of BFS, and how it happens. Take an example and how it happens. Take an example and explain them how BFS happens and how DFS happens. Okay, with that, you'll get very good marks if you write this table as well as you give an example and compare. Okay, so thank you so much. This is all about BFS and DFS. We have learned about how BFS works and how DFS works, and we have learned the theoretical difference between BFS and DFS, and also where it is used, the applications of BFS and DFS. I hope this should be enough for you to crack any question that is given on BFS and DFS. So thank you so much. Yeah.